Hey guys, today we wanted to get with you and show you we're doing a little experiment in-house. I know you guys, I wish y'all could be with us, but you can't, so we wanted to show you what we were doing to experiment with force and motion. We've talked a lot about friction and how it changes things, so today we've got this set up. We got two things you have to have when you're doing an experiment. It is a constant and a variable, and Mr. Morales is going to talk to you about constants and variables.
Okay, so when we have a constant, what do we think that means? So happening over and over again or staying the same, right? It just is repeating. So, did you nod the phone? That's hilarious. So, when we're talking about a constant right here, we're talking about something that doesn't change in the experiment. So in this experiment, we have different surfaces. As you can see, we're going to be using the tabletop, we're going to be using the foil, and the cloth, right? Magnificent cloth here, provided by Miss Tate, right? But the things that are staying the same are our ramp and the toy car. Okay? So, those are our constants. Now, when we're talking variables, like I just said, okay, variable is something that changes throughout the experiment. And in this experiment, it's the surfaces. We're using the three different surfaces. So it's something that changes in this experiment. Okay? Now, we are talking about friction, right? So we need to figure out which one we think is going to have the least amount of friction, which one is going to have the most amount of friction, and which one is somewhere in the middle.
Which is basically, when we're using our scientific method, is your first question, your testable question. We're wondering which surface this car will go faster on. We have thought that it would probably either be the table or the foil, while Mr. Herring thinks it's going to be the cloth.
Yeah.
So we have posed a testable question on which surface will the car travel the furthest. So there's our testable question. Now we have to make a hypothesis, what we think is going to happen. That's our next part. We think, as science teachers, Mr. Morales and I think that the car will travel further on a smoother surface. That we'll get more distance on a smoother surface. So that is our hypothesis. So now we've got it, that was our hypothesis. We made our prediction that that's what's going to happen. So now we're to the point where we're going to test our hypothesis, which is, again, part of our training. So here we go. We're going to take our car. Remember, none of this is going to change except for the surface. So when you're doing any test, you've got to do it more than once. So we're going to do it 3 times. Hopefully, all of our results are going to be close to each other, because if they're not, then something's kind of weird. So we want every one of our results to be pretty close. As far as on this surface, we want the 3 results to be close, as well as when we change it. All right, let's do it.
All right. Okay.
Oh, sorry, guys.
Oh, that was pretty
Awesome.
good.
Now, we also have to figure out where we're going to measure from. So we're going to pick right from the very end of the ramp. It doesn't matter where I measure from, as long as I make it the same every time. So if I measure from the end of the ramp to the front of the car, what we got over there? About 30 and a half?
Yep.
30 and a half.
30 and a
Almost on the
half.
dot.
30
Yep.
and a half. So there's our first result, 30 and a half. So let's try it again, Mr. Morales.
All right. So we're sitting at 30 and a half for trial number 1.
Bing.
Oh, that went way further, it seemed like. No?
Actually,
Actually,
whoa.
30 and a half.
Yep, 30 and a half.
I said
Oh,
close, not exactly the same, Mr. Morales. We need to vary this.
30 and a half, and the second one was 30 and a half. All
Here we
right,
go.
Here we go. Here we go.
Go, 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 go,
That
go.
looks like it went the
Oh,
exact same.
he got right there and backed up. Did you see it?
No.
It's like he threw it in reverse.
moved.
Okay, here we go.
All right, Valentine's Day.
Oh, it's less.
Ooh.
And even with moving, it was probably
About
only at about
29
29 and a half.
Yeah.
We're going to say 29 and a
We'll
half.
say 29 and a half. Yeah.
But still, those 3 results were close. I didn't have one that was like 50 inches and one that was 3 inches and one 29. They all were right around that position.
Yep.
So that was on the foil surface. So now we're ready to change it and put it on a different surface. What are you going to use next? The table? The table by itself? We could make a giant foil ball. with
We
that.
could make a giant foil ball. Yeah, we'll use the tabletop next.
Here we go.
All right, just regular tabletop surface here.
Really nice, clean. See how nice this
Yeah, look
tabletop
how
is?
it's not scratched up or
Not
anything.
scratched up, brand new, provided by HPA. Here we go.
And away.
Oh.
Ooh. Okay. Okay.
Oh, it rolled again.
To go backwards
Did
again?
you go backwards?
With going backwards, guys, you can agree with me at home. That was probably 30 and a half.
Yep. Oh
Okay.
my goodness, 30 and a
Oh.
half. Okay. Maybe I'll give it a little juice this time.
Oh, here we go. Second time, racers, start your engines.
What is it real
I don't
fast?
know. Is there a hump in the table, maybe?
Yep.
Maybe the table's got a hump. I would say 31 and a half is what I would
31
say.
and a half
Man,
with
might
it
be
moving
closer to
back.
32, but-
Actually, it moved. That's
moved
about
pretty
as-
far, right?
It didn't actually move that far.
Oh, okay. Well, then we'll say 31.
Guys, you can choose to agree or disagree with the cameraman.
Hey, run this tape back. Run the tape back.
With his beanie. Here we go.
Oh, that was pretty far.
It
dude.
was right there.
Okay, we'll scoot her up.
31 and a half?
31 and a half.
31 and a half.
So we're riding the same as a full surface.
Yeah, just about, right?
Okay.
Wow.
Now I'm
Okay.
starting
Let's put the cloth.
Just give our-
I'm kind of starting to wonder about the curvature of the table.
No, this is a brand new high quality table.
Yeah, this is brand new. This is brand new. All right.
So, kids, this is also a lesson in sarcasm.
No.
No, of course not. No, watch out for that ramp
Easy,
take.
easy
Yeah,
there,
easy with the ramp
easy there.
take, man. All right, we're gonna have to hold her taut. Actually, no, we're not.
It's
'cause
okay.
Tater
I'm
tot?
gonna let you do it. Tater
We're gonna let
tot.
me do it. We're gonna let me do it. Just put me behind the wheel,
Push this over.
ladies and gentlemen.
Pull that way a little bit so it's not bigger. No, so that was a little curved
Pull
there.
that corner. That way a little bit.
We
So-
just asked you to run the camera, not give us advice.
I mean, I'm telling you what I'm seeing. I give advice Monday through Friday.
Oh,
Okay,
man.
here we
Free
go.
of charge.
See what happens when you guys don't jump on the Zoom. We
See,
go,
we got too much time on our hands.
Ready?
Here goes.
Yep.
Oh, faked you out. Okay, we're looking at
Whoa.
30
All right.
and a half.
All right, prediction. Do we think it's 30 and a half?
Absolutely not.
Or about 15.
15
15 and a quarter,
15
maybe.
and a quarter, sure.
Maybe.
Oh, goodness.
I don't think that Mr. Herring's prediction is going to hold true on
I don't think so either.
this.
Yeah. I don't think.
Oh,
It's a Valentine's Day card. You see what it says on it?
yeah, it says Valentine's Day
That's
2017.
awesome.
Good year.
That's
Was
like
it? 15.
15.
That's exactly a 15, I would say,
Yeah.
just
Yeah.
about, you
Couldn't get
know.
any closer than that.
Ooh, it's actually Hot Wheels brand.
Hey, only
Guys,
Hot
we
Wheels
only
brand,
use the finest.
highest of quality
That's right.
race toy cars here.
And in honor of Valentine's Day coming up, we use
Yep.
this one. They can't do that. That's not making it a constant.
All right. Now that would have changed. That would have added in another variable, right? All right.
It curved on that one.
Oh,
14.
14. Wow, you hated that one.
So we
Little
have
slow
been able to
start.
see as we were doing this that the surface did make a difference. Because of the friction that was applied underneath the wheels, it slowed or sped up the car going across the surface. So that was the purpose of our experiment today, was to find out which surface that the car traveled furthest on. And it's kind of almost a tie, wouldn't you think, between just the table and the foil?
I would
It
agree.
didn't make too much of a difference. Now maybe if we had been on some other type of surface, it wasn't maybe quite as smooth as the table, that the foil might have made it different, but we saw that this friction made it slow down. Just like the friction on your bicycle, your brake on your bicycle, it just pushes together against your tire, causes the friction that slows you down. So friction does affect force and motion.
Yep. All right, guys. That's all we have for
That's all we
today.
got for today.
Yep. You guys.
Deuces.
have a
Find
good
us
day.
on Zooms.